welcome to another episode of Let's Make It. This is episode number 62, and it's recorded on, I think today is the 16th of June. And as always, I am here with my co-host, Bob. How's it going, Bob?
It's going good, and it is the 16th of June.
It is good. I just wanted to make sure. Yeah, that's right. The Friday 13th was last Friday, so it would make today the 16th. Yeah. So today, you can kind of see in Bob's background there what we're going to talk about. But before we go there, I just wanted to thank everybody for tuning in and spreading the word. We're still getting more and more downloads every week. It's kind of amazing to me how things just keep growing. But I do want to thank everybody for that. And the other thing I've noticed this week, I logged into our site where you can buy the t-shirts and everything, and people have been buying t-shirts. So I'm going to challenge you to send us a picture of that, because I set up that site and basically never go and even look at it. And then I was in there looking at it to see if anything new was out there, and I realized people were actually buying I saw at least one shirt, a couple coffee mugs, and things like that. So take some action pictures and send them in to us. Would appreciate that as well. Before we go into our first thing, I want to talk about something that I've been kind of playing with, and I think bring this up here. So I've been playing with quadcopters, and I'm actually looking to build a hexacopter at the same time as the quadcopter for doing some video stuff. But I want to bring this up here and show you, because this is something that I'm starting to play with, and it's an open source system. So let me get it up here. With. So this week Bob's going to talk about something that he's been struggling with, and actually it came from one of our viewers. Jim up in Canada had asked us questions about this and got it to work, and he struggled as well. He's in the chat room, so if you're in the chat room, he can attest to how complicated it was to get to work. Bob struggled with it for how long, Bob?
I've been fooling with this off and on for, 3 weeks now?
Yeah, something like that.
And finally got it working yesterday afternoon.
So, yeah, he's really new up to this, so it's going to be a little bit new to Bob as well. In fact, he's still playing with it and learning things. He's going to come back probably and do another episode on what all you can do with it. But can you give us a little bit of a description of what it is?
Well, yeah, it's called the Arduino TV Out project. And I tell you what, let me switch to my desktop, and then I can show you the website. Start. Close that. Okay. Get rid of this guy. All right. This is the project, and it's actually it is a nice little project, and it in the end I have this connected just like the this diagram shows. I am using an Uno, so I'm using pins 9 and 7, and I've got it connected to ground. And this is, here it is. And you can see I've got my 2 little resistors back here. I've got my RCA cable. I do have it powered. It is connected to the computer right now via the USB, but I am running it off of a 12-volt power supply right now. And so it is connected just like the diagram shows. But I had a horrible time getting it to work. And I think, I'm not 100% sure about this, but I think what the problem is that the tolerance on the frequency is so small that if you don't have the components just right, then it doesn't work. And I ended up with a lot of times just having little flickers along the bottom of the screen, like it was just out of phase. And in the end, I think a lot of it may come down to this, this 1 ohm and 470 ohm resistor right here. And the way I've looked at it is that if you take 1,000 and divide it by 470, and forgive me for the math, but you get 2.1276. And I finally found a combination of resistors that would give me 2.1299. And that's what we're looking at right here. And I was using, I had my multimeter out, I was checking resistance on the resistors, and finally found these two. I'm using a 976 ohm and a 454 ohm, and that gives me the ratio that I described. The irony is that this is within the 5%. I'm using 5% resistors, and it is within the 5%. So it's annoyingly difficult to find the right combination, but they are there. I also ended up, here are all of the libraries. You can tell this was a very active project back in 2010. And I tried many of these libraries, and the only one that I ended up getting to work, and that's what we're watching right now, is this TV Out Beta 1. So I put that library in, and this is the actual code. This is their example code. And to be honest, since I just got this working yesterday and had a job to had to work today, I haven't had a chance to read the library. I haven't had a chance to read this code, but it is working, and it's just what you get in the demo. I think the only thing I've changed is I did put Arduino Uno right here, and I fixed that little space, and you can tell I do have it connected, and it is working. Here, I'll leave the TV on the screen, and I'll skip it. Skip me. You don't need to see me. And I'm sorry it's backwards. That's the way it's. But it.
That's Skype.
Yeah, that's Skype. But it is working. Let's see. Here, we'll just do something fun. Here, I'll get a little plug-in for us. How about that? So it's a It is a nice little project, and I guess for the future, I'm going to play with this software, read the library, see what's in it, dig around in it a little more, and see what we can do with it. Unfortunately, I just got it working yesterday. So,
do you know what resolutions it supports?
It is a standard NTSC. And by default, I read that it's in the notes, but it's also right here in the code. It's a 120 by 96. That's the pixels they're using right now. I don't know how much tolerance that there is in that yet. And I must admit, I do like this rotating cube they programmed in. Now on the screen, on this screen, it does look blue to me. Is that the way you see it?
Yes.
When you're looking at the actual television, it actually looks gray.
Okay.
So I don't know if that is a function of the television that I'm using, because this is actually I bought it as a monitor, and it just happens to have a composite in. So I'm not sure if it's a function of this monitor or if it's something the Arduino is doing where it's getting...
It could be the camera, or it could be a bunch of different things.
Or it could be, yeah. Well, I think the camera is giving it is taking the gray and turning it blue, but I'm not sure why I'm getting the grayscale that I actually see on the screen. So
can you do anything with colors that only grayish, gray or black and white type colors?
In what I've read so far, it only supports the library only supports black and white.
Okay.
And that seems to be more of a function of the Arduino's limited capabilities and mixing the signals that you have to get a color video than it is anything else. I think if you had a more powerful microcontroller, then you may be able to do something with it. And it does tell us, from what I've read already, the whoever wrote this, they've got multiple fonts written in. They do have, they are using the Arduino's interrupts. But I haven't even read the library to see how much, what refresh rate they're using. I'm guessing it's probably 60 hertz.
So Jim in the chat room, who's experimented with this, and it actually came from him, says reverse pins 7 and 9, and it gets brighter than gray. And he says it is black and white only.
Yeah, and I think that's a function of the composite signal. Well, let's just try that.
Nothing like live TV.
Nothing like live TV. So
we'll just blame it on Jim. Sorry, Jim.
We'll blame it on Jim. So reverse pin 7 and 9.
Wow, yeah, definitely.
Yeah, it definitely is a little. It looks a little choppier, though.
Yes. Yeah, it's not as clear, but it definitely is brighter.
Yeah, it's brighter, but not as clear. And on the screen, to me, it looks the white of the cube is a little brighter, but the gray background is just as gray as before.
Gotcha.
So I think I'm gonna switch, and just so we have, you can actually watch me switch the pins. Oop. There we go. And we're back. So
the shapes you're doing, so like that's all something that's like in the library to do. Is that correct?
This is part of. Here, I'm going to restart the Arduino. That cube that we're seeing, Yeah, this is this TV out logo. That's a programmed feature. You can put text onto the screen, and here we are. Okay, here's the schematic. That's a pre-programmed file. It's just a two-dimensional array. In C, you do the fonts. I mean, here we are. I mean, this is where we're at in the code, and do some basic shapes, and then once you've passed this the intro here, then you go back into this running this cube forever.
Okay.
That's just the way the demo is set up. So, and I just haven't had time to play with it and see what all I can do.
So, can you reverse your camera back and reset the Arduino so we can see it from the front side? 'Cause the words are backwards. You definitely can't read the words that way.
Let's see. Did you get... let's see. Stop sharing screen.
Yeah, I think where you just were was probably forward to us.
You haven't gotten the video back yet, have you?
I have not. I got a little spinny thing, though.
Yeah, the little spinny thing doesn't do you a lot of good, does it?
No, not at all.
All right, let's...
Have the Arduino.
All right, there's the Arduino. And my camera, there we go.
Yeah.
All right, so let's, let me go ahead and restart this so you can see it all correctly. So there's their TV out logo.
You said it's just a two-dimensional array, right?
It's a two-dimensional array, and the schematic that's going to come up here in just a minute is also a two-dimensional array.
Okay.
And those are programmed in. Those are part of the library. That's part of the library package. And then they've programmed in some different fonts. And then we get back into these basic shapes. And then the random cube.
Okay. So you think about some of the things that you could actually do with this. I know one of the pictures that Jim had sent us was looked like a scoreboard. And so anything you have that takes composite out, which is getting harder and harder to find, you can pretty much do with this then, within reason. Because it's obviously the quality of the image isn't going to be real great because of the low density or the low dimensions on the monitor. But for basic stuff, I think it's kind of like the old Atari games were this kind of quality.
Well, and in fact, if you look at the download section of this project, there is an Arduino Tetris zip file that apparently you can use. I've only glanced at it, but apparently you can use it as either old joysticks or variable resistors.
To do like a controller?
To do a basic controller, yeah.
Is there Pong?
I'm guessing that, this is pretty cool. This is about what a Pong display used to look like. So, and I remember Pong connecting it to my TV. So,
yeah.
So it was pretty close to this.
Yeah, all you need is a little ball shape in the middle. And if you have the two-dimensional array and two little bars, you can probably do it pretty easily.
You probably could. So, and Arduino that probably has more horsepower than what the Pong did.
Yeah, probably does.
Controller did way back when.
The physics are probably pretty simple too. You think about it.
Yeah. So I guess I'll be playing with this in the future to see what else you can do with it. But Yeah,
you're right. I'd be curious to see if you can get the qualities a little bit better as far as the horizontal and vertical lines.
Yeah, I think if you could increase the resolution, and that's what I'll be looking at. If you can increase the resolution, even if even if you give up speed, because this cube design it's moving pretty quick.
Yeah.
You may be able to give up speed for better resolution.
Yeah.
But I got to look under the hood and see what's in there.
And you're running this just on a regular Arduino Uno, right?
Yep. This is an Arduino Uno. The only thing that's special about it is I am running it on an external power supply.
So does the library support other Arduinos?
Indeed it does.
Okay.
Sorry.
That's okay.
Okay.
So, in the chat room, Jim says that Pong is there. Is there too, and that a 10K variable resistor works.
Okay.
So you can make your own little slider. Just go get a 10K sliding potentiometer, and there's your Pong joystick you had when you were growing up.
That's right. So maybe we'll do a Pong demo.
So the reason I was asking about the other Arduinos is, the faster Arduinos may be able to do a little bit more with it if the Uno is taxed already.
Yes, and apparently they are using the SRAM, which Uno has very little SRAM on it.
So they're probably building the image in the SRAM and then sending it out.
I think that's what's happening.
That'd be pretty typical for a video card. So I think that'd be probably normal.
Yeah, so I'd have to go look at the specs on a Mega and see if it has more SRAM. I think it does.
It definitely does. It definitely does.
Yeah, so
that could be the resolution issue as well. Maybe you're at the max SRAM, the resolution that you're running right now.
I may very well be. And I have seen where when I've looked, as I've been working with this and Googling, I have seen where people have complained about. If they're trying to do things too quickly with the Uno, because the Uno is using interrupts to get the display out, it's having trouble processing other things.
Yeah.
So, which makes sense.
Yeah, it makes total sense. I mean, it's not really designed to be that strong with CPU. It's designed for learning and education, so it's pretty impressive it's doing it anyways.
Yeah, but this could be, if you had a simple display that you wanted to have, I think Jim's example was a scoreboard. This is perfectly good for a scoreboard.
Yeah, because there's not really anything that's fast updating, so it's kind of static and changes when the score changes, which isn't not unless you have a clock, but it's still only once a second for a clock. So it's still in computer time, that's nothing.
Yeah, so if you had an old monitor that had a composite in for just a few bucks, you've got you've got a display.
Yeah, and plus also some older video systems like projectors and things like that take a composite in, just like the monitor does. I mean, it's still pretty common in projectors to get that kind of input on it. Yep,
that's right.
All right, so are you going to work on something in more uses in the future? Maybe get another episode.
I'm gonna work on this a little more. I'm also gonna go back. I have gotten a lot of requests for debugging the GPS unit that we did. 6 or 8 episodes ago, and I got 2 more requests over the weekend. So there's some software that you can use to help debug a GPS, and so I think I'm gonna take backtrack a little bit and hook up that software and show how you can debug the unit and figure out if if it's the code on your Uno, if it's a setup problem, are you actually reading raw data? It's nice software, so that'll be upcoming.
Okay. That was weird. I had something take off on its own. I don't know what happened there.
Live TV. I guess we're done for the night.
Yeah. They're not quite. So a couple weeks ago, I mentioned about doing some sensors for beehives and stuff like that. So I was starting to play with that, and I'm trying to figure out how I can read what frequencies are inside of a beehive. Have you ever done anything with that before?
Well, it'd be an analog signal.
Yeah. Because apparently bees make different kinds of sounds whenever certain things are getting ready, like they're getting ready to swarm, things like that. They have different sounds they make, and people have documented what these frequencies are. So if you can read the frequency, you may be able to tell that your hive is too full and the bees are getting ready to swarm to create another nest, things like that. So it'd be like a pre-warning of things you got to fix. So it'd be kind of interesting to be able to read it. I mean, some people will actually record them and come back and listen to them every once in a while. But if you can take and you can compare it to a particular frequency range, you know what's going to happen. You could almost like text somebody and say, "Hey, your hive's full." So,
or your hive's about to attack your neighbor.
Yeah, and
which, depending on if you like your neighbor, may or may not be a good thing.
Your neighbor may find that their downspout now has a new hive on it, but
that's right,
because they're getting ready to swarm. But that's the kind of thing I've never actually read or listened to audio on Arduino, so I was going to start researching that a little bit. But I didn't know if you had any history on that or not.
I haven't done anything with that, but I've never had occasion to either. Reading, I know that you can read an analog signal back in, but I haven't done any processing with it.
Yeah, so I'm going to be researching that here in the next couple of weeks to figure it out.
You'd have to figure out a way to calibrate the microphone to make sure that the frequency you're reading is correct. So.
Right. Yeah. There's all that involved into it. Make sure it's the right thing. The temperature and the humidity part is actually very simple. I mean, it's just a number of different chips can do that. DHT11 is probably what I'm going to use. But I like to stick a microphone on that same board. If I'm going to put a board in the middle of a hive, I like to have everything on one board. So
yeah, that's right.
Been experimenting a little bit with the DHT11 and moisture, and I think it'll be fine because the hive is more moist and warm than the outside normally is, even in the wintertime. So I think it's going to be okay. So I haven't stuck it in a hive yet to find out what the bees do to it. Oh, there's some things you can put around it the bees won't bother. It's like a kind of brass cloth looking stuff, and they don't seem to bother that too much. They won't put propolis all over it and make it all sticky or anything. But that's something I'm still playing with that. I got some code written. I'm learning CAN bus, because if you got more than one hive and you want to communicate back, I have each one of them communicate back. I think I'll communicate to a central controller or something. So I'm playing with CAN bus a little bit too, which is not as simple as one might think. It's a little bit of a complicated protocol. So I may be doing an episode here in the near future with CAN bus as well.
Okay. And of course, if somebody has an idea, that's where this TV Out project came from. Is somebody's idea and people asking about it.
That's right. That was Bob. Thanks, Bob, for that. That got us thinking. You sent that in a while back. And what is it? 6 or 7 weeks ago, maybe. And Bob finally got around to messing with it. So definitely appreciate any feedback like that on things you want to see. That's always helpful.
Yeah.
Gives us the direction to go, because we want like to do things that you want us to do, and we don't know what you want to do unless you tell us. So
that's right.
It's always good. We do appreciate the emails. I think I got like 2 emails yet to catch up on. I'm gonna try to do it tonight before I go to bed. So I'm getting a little bit better at catching up on emails.
Well, I got quite a few over the weekend, but I'm caught up right now.
Yeah. All right. So thanks, Jim, for hanging in the chat room. So you, Chris, thanks for showing up. Definitely appreciate it. Yeah. Jim said he had a clock in his example. Oh, okay. He's gonna make a video and send it to us. That's cool.
Well, that was something else, because I used a different library than the code that Jim gave us.
Mm-hmm.
I couldn't get it to work.
Oh,
I never got his code to work because he used a different library than what I ended up finally getting to work.
yeah. So it seems a little fidgety.
It is a little finicky. The tolerances are very tight. So
you said the code hasn't worked on it since 2010. You should pick up the code and maybe clean it up and get it working good.
Well,
as a side project.
Don't think I haven't thought about that once or twice already. So, a lot of the library support right now looks like new devices that need to be added. Functionality looks like it's pretty much there. It's the devices, but yeah, there's probably something in the libraries that I'm going to want to tweak or change or manipulate or otherwise fool around with. So
yeah, because obviously if the code that Jim sent us doesn't work with your library, there's some kind of disconnect there that needs to be cleaned up so it should work with everybody's stuff.
That's right.
Jim said he's not an experienced coder yet.
He'll get there.
Yep, he'll get there. All right. So do you have anything else for tonight, Bob?
That's it for tonight.
All right. So this time it was going to go off, and it's going to mean to go off.
Okay.
All right. We'll see everybody next week.
All right. Good night.
All right. Night. For show notes for this show, contacts, and more, go to the TechZen.tv website where you can get show notes for all of our shows. We love to hear from our viewers and listeners. We have an email, a Twitter, and a phone number where you can contact us for each show. For details, visit the TechZen.tv website and get the show details. You can also make a video and upload it somewhere like YouTube or Vimeo and then just send us a link. You never know, you may see your video in a future show. You can get all of our shows delivered automatically to your favorite device by going to your favorite podcast website like iTunes and subscribing. Each of our shows also has a YouTube channel you can subscribe to get regular updates. Our shows are also available on most internet radio networks like Stitcher and TuneIn Radio. You can also watch and listen to our shows on Xbox, TiVo, and Roku.